Hey guys, so this week I have some good news. We only have one new lesson of the trig unit, and then I'll probably have you do like a quizzes or something supplemental to that. So today's lesson is on trigonometric functions of any angle. Typically what we've done in the past is just angles between 0 and 90, and that's why we were using like those special right triangle examples. But what we're going to be finding now is trig functions for anything between, it could be greater than 0, less than 0. Typically it's going to be between 0 and 360. But the first thing we want to look at is this diagram here in example 1. This diagram is for determining which trig values are positive and which are negative depending on the position of the angle. Okay, so remember that our angle can, the terminal side can lie anywhere between 0 and 360. So we always start at this right here. So depending on where the terminal side is, which is the ending side, it could lie in one of the 4 quadrants. So this is 1, 2, 3, or 4. The all, if it falls in quadrant 1, that means everything is positive. So all trig functions are positive. If it falls in quadrant 2, all students. If you had to guess, what S goes with students, so this is where sine and its partner, its reciprocal, which is cosecant. These are going to be positive. T in the take quadrant, take is going to be tangent and cotangent are positive. And then lastly in the C quadrant, it's going to be cosine or secant, which is the reciprocal. Those are what's going to be positive. Everything else, so like if we were trying to take the cosine of something that falls in the second quadrant, we would find, the cosine in quadrant 2, then it would be negative because only sine and cosecant values are going to be positive in quadrant 2. All right, we'll go through a couple examples and it'll make a little more sense once we get some actual angles. All right, here's another diagram. Let Q be any angle measure in standard form. X, Y is any point except the origin on the terminal side of Q. So X and Y is just any coordinate pair. R is our radius, and what this always forms is a triangle. So here, notice we have the terminal side where X and Y are. We can form a triangle, a right triangle specifically, with the x-axis. We're always able to do this. So the sine of theta is equal to y over r. So if this is our angle right here, because that's the inside of the triangle that's touching the origin, the opposite side, this is our x, this is our y, and then this is our r. So sine is opposite over hypotenuse. So this is the opposite side, this is the hypotenuse, and this is the adjacent. So it makes sense. Y is the opposite, r is the hypotenuse. Now if you look at cosine, cosine is adjacent over hypotenuse, which makes x over r, and then tangent is opposite over adjacent, which is y over x. So we see all of those right here. Now that's the technical form of things, and then there would just be the reciprocals for cosecant, secant, cotangent. And with all of those, y cannot equal 0. Otherwise, we'd get an undefined answer, which we will get later on. All right, so don't worry about that too much. That's just like a technical way of doing it. Not a huge fan of that diagram, but here's our first example. So we want to let -4, -3 be a point on the terminal side of theta. So this is just some point, and if you think about where would -4, -3 fall, that's got to be down here in quadrant 3. Okay, so we have an angle, starts up here and goes down, and then we'll just say that this is our point right here, -4, 3. So if I were to make a triangle, -4 goes to the left, -4 units, and then down -3. So this is our angle right here because we connected that to the x-axis. So we want to evaluate the 6 trig functions. So we are going to find, this is our theta, we're going to find the sine of theta, the cosine of theta, the tangent, And then we're going to find the reciprocals of those, which is cosecant, secant, and cotangent. All right. Now, typically we don't like to have negative values with a triangle, but those are just the coordinates. If you think about this, though, we need to figure out what the hypotenuse is. So to find the hypotenuse, just like in previous lessons, we're going to use the Pythagorean theorem. So we know that one side has a length of 3, one side has a length of 4. So those are a and b. Remember, Pythagorean theorem is a squared plus b squared equals c squared. So here we're going to get 3 squared plus 4 squared equals c squared. And if you know your Pythagorean triples, this one works out to be a pretty nice answer. So 9 plus 16 is 25. And we take the square root, and we get 5 for the third side. So this is going to be 5. All right. Now this is where that all students take calc comes into place. So A, S, T, C. Since we're in the T quadrant, we need to think about what's going to be positive in the T quadrant. And if we go back up to our little grid here, it's tangent and cotangent that's positive. Everything else is going to be negative. So the sine of theta, sine is opposite over hypotenuse. So the opposite side is the negative 3. So this is our opposite. This side here is our hypotenuse. And then this is the adjacent. So we get negative 3 over 5, which is a negative value, which is what we want. And then the cosecant is just the reciprocal. So it would be negative 5 over 3. Cosine, adjacent over hypotenuse. Cosine is still going to be negative. It's going to be negative 4 over 5, adjacent over hypotenuse. And then the secant is the reciprocal, negative 5 over 4. And then tangent. Now, these are going to be positive. And if you think, well, why is tangent positive? So if we think about the opposite over the adjacent, negative 3 over negative 4. When you divide two negatives, you get a positive. So you get 3/4, because that's the opposite over the adjacent. And then the reciprocal is 4/3. Okay. Now, every single time you have something in quadrant 3 that's tangent or cotangent, it's got to be positive because you have a negative over a negative every single time, because all of the quadrants or all of the coordinates in that quadrant are negative and negative. Okay? But sine and cosine, those are going to be overall negative values. Let's try here with a different one. Let 3, negative 5 be a point on the terminal side of theta. Evaluate the 6 trig functions. So 3 would be over 3 down 5. So that would be, let's say we got 1, 2, 3 down, 1, 2, 3, 4, 5. So that's about right here. So let's say that our angle right there. So this is 3, negative 5, which means it's over 3 and down 5. We are ASTC. We are in the C quadrant, which means cosine and its reciprocal secant are going to be the positive values. But we still need to find that missing hypotenuse. So to find the hypotenuse, we got to use a squared plus b squared. So 3 squared plus, technically it's negative 5 squared equals c squared, but still going to be positive. 9 plus 25 equals c squared. 9 plus 25 is 34. You're not always going to get a nice number, and in this case, we get the square root of 34. I prefer it if you left it as the square root of 34, and that's how I'm going to do this problem. So this third side is the square root of 34. All right. So just like the last one, we still need to find the sine, cosine, tangent, and then the reciprocals. Someone needs to remind me to write these in for next year's notes. All right, so sine. Here's our angle right here. It's the one connected to the origin. So there's theta. So the opposite side is this -5, the adjacent side is that 3, and then square root of 34 is the hypotenuse. So we want opposite over hypotenuse, which gives us -5 over the square root of 34. To get rid of that, we would multiply the top and the bottom by the square root of 34. So the final answer is going to be -5 square root of 34 over positive 34. Sorry, I don't have a lot of room. And then the reciprocal of that would be, if we were to just flip the original part, it would be the square root of 34 over -5. And then for cosine, we get, now it's the adjacent over hypotenuse, which is positive 3 over the square root of 34, which becomes positive 3 square root of 34 over positive 34. And then the reciprocal of that would be the square root of 34 over 3. Now these are positive because we're in that fourth quadrant, which is the cosine quadrant. Okay, and then tangent. Tangent of theta is opposite over adjacent. Opposite is -5 over 3, and then the other one is -3 over 5 because it's the reciprocal. So there are the three angles that we have. So the biggest thing is for these problems is first to identify where does your quadrant lie and then build your triangle. So that's what I did first. And then you want to think about, well, what's going to be positive, what's going to be negative, and find all of the missing sides of the triangle. So we had to solve for that square root of 34 by using the Pythagorean theorem. And then I just identified what's my opposite, what's my adjacent, what's my hypotenuse. If it helps, you could build this triangle outside of the figure, give yourself a little bit more room. You know that this top side is 3, this side's -5, and then this ended up being the square root of 34. Here's our angle right here, and then just do opposite, adjacent, hypotenuse. Whatever easiest. I apologize, this is a little messy, but it is what it is. Okay, next we have, if the terminal side of an angle in standard form lies on an axis, then the angle is a quadrantal angle. It's one of my favorite words in math. So the quadrantal angles are going to be all of these right here. So if I have my x and y axis, it's all the extensions. So whenever we have these, we think of these as 0, 90 degrees, 180 degrees, 270 degrees, and then if we complete the full circle, we get back to 360. All right, so if it ever falls on one of those, that's when we're going to have these special situations. So the first one, the way that we think of this, it's r and 0. R is the radius. It's because we can't build a triangle that connects to the x-axis, so you have to think of this in a different way. I'm not a huge fan of this diagram, so I'm going to show you how I think of these. The easiest way to think of this is sine is equal to the y value, cosine is equal to the x value, and then tangent is equal to sine over cosine. So which would mean y over x. Okay? Because these are going to be coordinates for when we do this. So we want to evaluate the 6 trig functions of theta equals 90 degrees. So what this means, theta equals 90 degrees would be a right angle. So our point is going to be right here. Whenever it's on one of these points, we're going to think of it as just extending out 1 unit. So if this were to go 90 degrees and it goes up 1 unit, that coordinate would be 0, 1. Now earlier I told you to think of sine and cosine as x and y. So if we're going to find the sine theta, the cosine of theta, and the tangent of theta, this is x and y. Sine is the y value, so in this case our y value is 1. And then the cosine is the x value, which is 0. And now tangent. Tangent is sine over cosine, which would be 1 over 0. Can you divide by 0? The answer is no. So what we're going to put for this is undefined. Now we need to do the reciprocals. So secant, cosecant, and cotangent. The reciprocal of 1 is just itself. So secant, reciprocal, those are going to be the same. Now, cosecant, you can't have the reciprocal of 0. So because then you would be taking, I'll do it off to the left here, 0 over 1, and that becomes 1 over 0. Doesn't work. So this is going to be another undefined, and you can just put UND period. Now cotangent, however, you'd think that the reciprocal of undefined would be undefined. But the reciprocal was 1 over 0, and the reciprocal of that is 0 over 1, which is actually 0. So the reciprocal of undefined is 0. Kind of a weird concept. Hopefully that's not super confusing. But these would be our answers here. It is okay to get undefined answers, and it is okay to get 0. Just remember that undefined is when 0 is on the bottom, and if it's on top, that's okay. All right, now we have theta equals pi. Well, if you remember where pi is, if we were to convert that to degrees, we go pi over 1 times 180 over pi. We would get 180 pi over pi. Pi's go away, we get 180 degrees. So 180 is going to bring us all the way over to here. So like I said, we're just going to extend, if it falls in one of these units, 1 unit. So if we go to the left 1 unit, we get 0, negative 1. So not 0, negative 1. Negative 1, 0. All right. So negative 1, 0 is what we want here. So we need to find sine, cosine, tangent. So the sine for this problem, sine is equal to y, so it's 0. Cosine is equal to x, which our coordinate is negative 1, and then y over x is equal to 0 over negative 1, which equals 0. So we have those. So now off to the side here, I got to do, I'm just going to do them down below, I apologize. Cosecant, the reciprocal of 0 is undefined, because then 0 goes to the bottom. The reciprocal of negative 1 is still negative 1. And then the reciprocal of cotangent, which was 0, 0 over negative 1. Remember, the reciprocal of 0 is undefined. So now we have the 6 trig functions there. Okay. All right, quick little recap on this. I know this seems like a lot. So if it falls here, this coordinate at 0 or at 360 is going to be 1, 0. If it falls at 90 degrees, or pi over 2, that is 0, 1. If it falls at 180, that is negative 1, 0. And if it falls at 270, that means it goes down 1. That is 0, negative 1. So the r value just basically becomes 1 in all of those. All right, those can be a little tricky. If you need help with any of those, please let me know. Hopefully this wasn't too tough, and this is the only concept that we have this week, so if you are struggling, please reach out. I still have office hours from 1 to 3 every day. I hope you guys are doing well. I know we had the news that we wouldn't be returning to school, which is unfortunate, but I'd love to hear from you before the end of the year. We're almost there, so keep up the good